Yes, very good afternoon. Hopefully, I'm audible to you all. Uh, okay, let us begin with the let us begin with the last chapter, and the name of the chapter is image segment, and the segmentation is a mean basically dividing the image into the multiple subparts or segmented into the different subparts. So that's why it is called as a image segmentation. And in this chapter, you are going to learn about understand the characteristics of various types of the edges found in practice, and understand how to use the spatial filtering for edge detection, and be familiar with the other type of edge detection methods and that go beyond the spatial filtering. Then understand the image thresholding using several different approaches. Then combine the thresholding and the spatial filtering to improve the segmentation. And familiar with the regional based segmentation and how to graph cuts and the morphological watersheds. And this is not a part of your syllabus, but you can just go through it. And the familiar with the basic techniques for the utilizing motions, and these are like excluded, but yes, uh, you can go through it. Now, the segmentation, as we know that uh, the segmentation means dividing the images into the multiple subparts, and it is generally based on one of the two basic properties. And what are those properties? That is, the first one is a discontinuity, and the another one is a similarity. So in the first category, that is a discontinuity. The approach is to partitioning an image into the regions based on the abrupt changes in the intensity. Such as, it is please noted that you have to remove this. There is no region, and because the region is based on the similarity. Now, first discontinuity, the edges are the example of a discontinuity, and the approaches in the second category, similarity, are based on the partitioning and image into the region. So that are similar according to a set of predefined criteria. Now, the thresholding, region growing, and regional splitting merging are the examples of this particular method. Now, what are the main interest to detection? There is a we can detect the point, we can detect the line, and we can detect the edges. Now, the focus of this section on the segmentation methods that are based on detecting sharp local changes in the intensity. The edge pixels are the pixels at which intensity of an image changes severely, and the edges are the set of connected edge pixels. So we will understand this line very clearly with some of the examples. And the edges detectors are the local image processing tools designed to detect the edge pixels, and a line may be viewed as a typical thin edge segment in which intensity of the background on either side of the line is either much higher and or much lower than the intensity of the line pixels. Uh, and we will also discuss with the lines give the rise to so-called roof edges. And an isolated point may be viewed as a foreground pixel surrounded by the background pixels. So we will do all the things in the upcoming slide. And please note that we have already done one experiment on the basis of the edge detection, and if you remember that, and we will discuss the theory of that in this PPT. So first is our interest in a detection of a point. So what is what we can understand with this. Now, here you can just see that in a first figure, this is an image, and this is a histogram. Uh, there is a horizon. Sorry, this is not a histogram. This is an intensity profile. Intensity profile that includes the isolated points indicated by the arrows. Just hold for a second. Uh, okay, here we are. There is a intensity profile, and the figure C, figure C is a subsampled profile. This is a subsampled profile. The dashes are the added for clarity, and the number of here we can just we will do step by step, and this is the intensity values of this intensity profile, and these are the two derivatives, and hopefully you remember this diagram. We have already done in the uh, there is a fundamentals of digital image processing, and we will just repeating this task. And this is the intensity profile of that particular image, and here you can see that in intensity is defining the intensity of a particular pixel, and this is a linear line. Here we are talking about at this there is a intensity profile is like that. There is a there is a 5 intensity here. Here we are talking about at this point. There is a 5 intensity. Then again there is a 5 intensity is there at this point. Then 4 intensity. This is a 4, and there is a 4, 3, 2, 1, 0. So there is a 0 is around here. And in this figure, the white is represented by 1 and black is represented by 0. So the 0 is 0 may be existing over there, and this is a 0, 0, 0. There is a 0, 0, and at this point. And please note that here we found a point. There is a point in which there is a the intensity of that particular point is existing over here, and so that we can put the intensity of 6. Then it is going towards the till the end, and this is a 0, 0, 0. And again, there is a 1 is there. There is a 3 intensity level is there. There is a 1, 0, 0, 0, 0, 0, whatever. And this is a 7 intensity level. This is 7, and goes on. And next is now let's next we have to do the find out the first derivative. In the first derivative, yes, you have to find the difference between the values or with the subsequent values, and here you can just check it out. There is a 1 and 1, there is a 0, but yes, here we have just initiated with this minus 1. There is a difference between 5 and 4. There is a minus 1 difference. It is decrease from the 5 to 4. So we can write it as a minus 1, and it is continuously decreasing. So it is we can easily write it as a 1, 1, 1, 1. And then here there is an increment from 0 to 6. So we can write it as a 6, and then decrement from 6 to 0. We can write it as a minus 6. So similar, we can just make this line, and the another one is the second derivative, which is derived from the first derivative. And in this, for the similar values, we can put the 0, and rest we can put the values, exact values. And here we can see that there is a minus 1 is there, and it is continuously constant is there. There is a minus 1, minus 1, minus 1. And so that for first minus 1, we have to put minus 1, and rest all the values are similar. So we can put it 0 over there, and then we can just do this. Here we can see that there is a 6 block because it is changing, and there is a one more important thing is there, and it when it is reducing back to the 0, then we have to write it as a 1, and similar in this way when it is coming back to the 0, then we have to write it as a 0. So So we will in a similar trend, it will go towards the further, and here you can see that in a second derivative, it is -7 is present, and why it is present? Because it is reduced or increased from 0 to 1 or 1 to 0, or means higher intensity to the lower intensity and lower to the higher intensity. And in a point detections, we can use this kind of a kernel mask, in which there is a the weightage of that particular mask is a 111, and there is a -8. So this is a mask we can use and we can apply over the different images, and which rotates in which scans the entire image and find the points uh, in between the image. So there is a point is there, and which can easily be detected with this particular mask. So in order to detect the line, we have to use one of these masks. And in the first mask, there is a horizontal line is present, and here you can see that there is a horizontal line, and there is a plus 45-degree line, and 222, and this is a vertical line is there. We just mark it as a, there is a positive 45-degree, then there is a 222 vertical, then there is a minus 45-degree. So we can use any mask, any one of them. And the next is once you will use this mask, and you are able to detect the lines, and the lines can be formed like this. These are the output, and first figure is representing the wire bond template, and this is a result of processing with the 45-degree mask, and this is a zoomed image, and this is a D1 is a zoomed image of the that is uh, of this at a bottom, and it may not be clear to you, but yes, this is a point where you can just highlight it, and this is a this point. So these are the zoomed versions, and the next one is representing that is figure E. So the E is representing the image of B with all negative values set to 0. So in which all the values have been which are negative are set to 0. And the last figure is representing the that is condition is there. If it is greater than that particular threshold value, then it is represented as a 1, otherwise represented as a 0. So this is a kind of a binary image. And now the next step is detection of edges. So that is a abrupt changes, and in this figure, and here you can see that there is a very idle case is there when there is just a very sharp change, and this is the idle case, and in which this is the intensity profile, and the 1 is represented over here and 0 is represented over here, and there is a transition, and and if it is a grayscale, and 1 is 0 is existing over here and 1 is existing over here. So this is very clear. This is a 0 and 1. This is a binary image. Definitely this is a binary image in which only two values are existing, and this one is a grayscale image, and whose values are varying between the 0 and 1. And here you can see that how this transition is occurring at this point. And so there is again the area over there, that is a 1, and the area over there is 0. So this is the entire transition zone which is varying from black to the white. Now, at a last, we can see it as there is an intensity profile in which the value is changing from 0 to 1, value is changing from 0 to 1, and then 1 to 0. So the 1 is actually over here. Sorry, that is the 1 is over here. You can just please ignore it, and the 0 is there, and the 1 is which is existing at a center. So these are the values, and there is a this is a location of a grayscale values. So hopefully you are carrying this point and how the intensity profiles are look like. And with this, if we will just see it as a improved version of this or a zoomed version of this particular circle, then it is viewed as this is a horizontal intensity profile. And once we will do the first derivative, then it is represented as this. And when we will do the second derivative, and as we know that first it is increased. For example, in a first derivative, there is a 0 and this is a 6. 6 is there, and in this case, there is a 0 is there, then 6 is there, and definitely minus 6 is there, and which back towards or there is a difference back to the 0 by minus 6. So there is a one line is there and the one line is there. This is the second order, and the line when it crosses towards the 0 or a 0 origin, then it is referred to as a 0 crossing. So in order to detect the edges, we can use the gradient function, and the gradient vector is nothing but it is representing the that is towards. Yes, here we can just remember this term gradient to determine the edge strength and the direction at a point. And it is also noted that the edge direction is perpendicular to the this one is a edge detection is perpendicular to the uh, gradient vector at the point where the gradient is computed. So here we want to compute the gradient, and this is a 90-degree towards the edge. So this is basic representation how we can do the detection of the edges. So, and these are some kernels, some examples of the kernels which can be used to detect the edges. And yes, in previous we have in a practical we have performed this private edge detection and the Sobel edge detection. Hopefully you all are remember that, and we have done. It may be your fifth or sixth experiment. So we have applied these two masks, and this kind of a mask is there. There is a -1, -1, -1, and 0 and 1. So, and another one, this is a for horizontal, and this one for the vertical pivot. And where the Sobel, in which this is a horizontal mask, horizontal Sobel mask, and this one is a vertical Sobel mask. And these masks are actually applied on the uh, images, and these are the some examples of the output images. And but here they have used a kanye algorithm, which is another advanced algorithms and used for the detection. And here you can just check it out and how the algorithms will be displayed to you. Now there is another point here. You can see that when we will see. Okay. We will just have to check it out. Uh, you can check it over here. So this is a point. This is a point, and there is a point. So here you can check it out. The edges are the edges are sorry. There is a point is there, but the lines are broken. So how we can recover these broken lines? So in such cases, we can use this linking edge points. So edge detections in normally lying only on the edges, and in practice, these pixels seldom characterize edges completely because of the noise and the break in the edges caused by the non-uniform illuminations. Breaks in the edges caused by the non-uniform illuminations and other effects that introduce a discontinuity in intensity level. So the edge detection is followed by the linking algorithms. And in order to perform the linking, uh, definitely it gives the meaningful information, and it requires the knowledge about the edge points in the local region. So we can use uh, local processing and the global processing, and here we can there's a local region, and then the second approach is global approach that works on the entire edge map. So the, yes, only these two processes are there for linking the edge, and the solution is local processing and the global processing. So this is a methodology what we can follow to perform the for the linking of edges. And first, you need to compute the gradient magnitude and the angle array, and then you have to perform the binary, or we can say it as a threshold functioning, and that I will explain in the next slide in detail. And then in a third point, you have to scan the rows of this G binary image and fill all the gaps in each row and don't exceed the specified length. And length is already defined by the L, and the gap is bounded at both ends by 1. And to detect the gaps in any other direction, rotate this binary image. Okay, by this, okay, yes, there is there is some conflict are there. Just hold for a second. Yes, okay. Then to detect the gaps in any other direction, rotate the binary by this angle and apply the horizontal scanning procedure in the third step. So first, we have to understand this binary. Okay, this binary, how we can get this binary information, and before that, we can just check it out how the linking this linkage will work. And these are the first one is representing the actual image of the vehicle, and this is a gradient magnitude image, and then horizontal connected edge pixels, vertical connected edge pixels, and then we have performed the all logical operations, and finally there is a morphological thinning procedure. And at last, okay, at last we are doing, yes, we will do the thresholding operation in the details, and it is very simple and important process. In while implementing this intensity thresholding, we can use this type of operation. This is a single threshold, and this is a dual threshold, and we can also say it as a multiple threshold. And it is in order to divide this intensity histogram, then we can use the one for the threshold value having greater than this particular threshold value, and we can set the 0 if the function if the intensity of a particular pixel is less than or equal to the threshold value. And this is here we can just mark it as a all the values below this threshold value is represented as 0, and above the is represented as a 1. But here, in the case of the dual or a multiple threshold, we can say it as a if the value is greater than 2, we can say it as a, and if it is like in between T1 and T2, we can say it as a B, and if it is less than or equal to T1, then we can say it as a C. So this is the concept of a dual threshold. And the last important topic is image compression, and we have also done an experiment on it, and but not on actual algorithms. And this is one of the best research topic. You can just go through it. So what is image compression? Um, I will send you. I will upload one paper where you can get the information regarding all the compression algorithms used for the different applications, such as for satellite imaging, for medical imaging, for digital normal digital images. So these are the actually image compression algorithms are generally defined into the still image or a video. So the video categories are defined as this, and the still are defined into further two categories. There's a binary, and another one is a continuous. So normally we are more familiar with the JPG, Joint Picture Expert Group, and I will also upload a paper where you will get all the information about the image compression. And with this, your syllabus is over. And if you have any question on tomorrow, we will do the experiments on the uh, we will do the experiments on different on we have left with the four experiments, and we will start with the with the seventh experiment and till the 10th experiment. And if there is any question, then you can please feel free to ask, and we have time now.